Okay, turns out I wasn't even recording, so we're going to restart this. The first thing I did was I fixed this up. It was a very simple fix where you just, I believe this line over here, I made a triangle and eventually got the right points out um, to get the correct angle and everything, to get the right right thing for this. Now I'm gonna just quickly explain to you what this diagram really means. I mean, I already showed you in my textbook basically. But did I ever write in words? Oh, I guess not. So, I mean, it's kind of obvious what it means. I mean, if you don't get it, this used to be way more, what's the word? Intensive. I made it more simplified, making it easier for anyone to read it. I changed this to this format. If you look at the previous format, it was like written by hand by my pencil and tablet, and it was awful. And then there's neither. And basically, if there's stuff over here and then stuff over here, this portion over here is the intersection, and then union means everything basically. That's why it says A or B. Um, basically U equals or, and this N shape equals and if it's neither of this thing, well, you're out of luck. Why is that important? We go into onto suggestive, we go to a domain to a codomain, and then there's one-to-one injective, and then there's this range vector over here. Now, if you know anything about, I'll explain it later. This was a real pain to write in Overleaf, honestly. But I eventually got it to work, which is shocking. So if you have a code domain like this and domain, now I like this picture I made because it kind of visually shows you what the range is effectively. When you have some numbers over here, I should probably explain that this is equivalent to numbers in this case. So when I did this, I was basically making a wedge that fit into this range. Basically, there's probably more numbers that can get into this, more than three in a range, right? Because it's like the after a function is inputted, like y equal x, the range is basically gonna be, well, it's gonna be infinity to infinity, and the domain is also gonna be infinity to infinity. Because the range over here in a function is the y-axis up and down, and then the domain is side to side kind of in a simple form like this. It isn't really true. I mean, I'll explain later. It doesn't really matter. So I was thinking about this and how to visually represent it. Now, if I was to say this is my domain. This domain is the input basically. And then you can say x equal to x equal to 1, and you can put it into here and then go to the codomain and you can come back to it. Well, then you have a range over here, right? Now, imagine if you could visualize to the extent of the frame of the domain. Basically, well, it's not infinity, but we'll pretend it is. And then these 3 points basically define the furthest edge of the domain. is what I imagined. And I said, okay, and I could put that over here and say this defines all the range. And I realized this visualization actually doesn't violate any rule. I'm don't think it does. And I realized, man, that works. That actually works. That visualization kind of works. Now, I would have rather have a rectangle, but I was doing overleaf over here, and that was a pain in the ass. I forgot which one was it. I was doing this, and I was like, I'm not making another point. I was making more points, and I was like, this is a pain in the ass. I mean, it's not really that pain. I'll show you why. Getting these numbers to look visually, aesthetically pleasing, because if it's not aesthetically pleasing, I'm gonna have to change it later anyway. So this was the most aesthetically pleasing I could have gotten it. So, I mean, I no, I could have done better. I just was lazy a little bit, but it was visually pleasing and it was like good enough. Um, now, now, if I had a domain of let me say x equal absolute y, the domain is infinity to negative infinity to infinity, right? And which makes this R, basically. Because R now, we all know what R is. So the domain that would mean that any like if you put x equal 1, x equal 2, anything will go in there. Unlike something like log, which anything below 0 is impossible to get. So for now, we're going to assume this. We're not. I didn't teach that yet. I taught you about absolute value, but the range of it is uh 0 to infinity, right? Because of the absolute value, including 0. So what does that mean? Well, there's other numbers visible, but you're not really using it. It's just there in the code domain. But nothing in the domain side can get to it. You can't break that range of numbers. Those if yeah, it's kind of hard to say, but if you were to assume that infinity can be drawn as like a point and make it into a plane of domain and make a bulbous, like that's kind of how I imagine this diagram to be, and it looks good enough, so I said, yeah, that's good. Yeah. Then I kind of went into a dialogue of possible inputs to outputs. So, well. It's a fairly common thing, I think, in education. You learn this pretty often. And we usually start with something basic, like y equal x plus 1. Now, we know that all the domain is the inputs possible. Now, domain is all inputs possible and all range is all output possible. Um, um, did I explain what a function is? I did not. Uh, uh, function has one output for one input. Note an input can the same output. Input yeah has no can an input can have the same output. A function has one output for one input. Note the input can have the same function output as another input another output, no output, but an input cannot have um, the same input for uh, output. No, the wording makes no sense because you don't know what I'm saying. Let me read this again. Note an input can have the same output as another output, but an input cannot have the same input for an output. Can I have a can I have a different input have but an input cannot have this have different for the same output. All right, if there's a mistake here, I'll fix it, but I think that's good. Now, what does that mean? Okay, so if you plug into over here any number to this, you can get an output. So think of like, I don't know, just uh, electric volt, and you get one over here. No, not electric volt, some kind of amplifier. Then you get Y equal 2, and so on, and there's a correlating match. Now, we use absolute value. I'll explain that. Over here, we use Y equal X squared. We know exponents, right? Now, here we use the fact that there's a negative 2 and 2 that can be the input. And the output will be the same, right? Now, here it says this is function assuming X is input, but if Y is the input, if Y was input is not a function. Um, it's not. It is not. What the hell is this grammar? It is not a function. Well, I'll fix that for all of them later. But you get what I'm trying to say? So if I flip them, they wouldn't be. But is a function. Right now is a function. Um, now if I were to go to Wikipedia, mathematics, a function from a okay. I don't know how it says okay Google. How it went to okay Google, but you get what I'm trying to say. Um, was this what was that actually? Because I don't think this thing has OK Google, or it's disabled, right? I don't know. Anyway, we're going to y equal negative x. Oh, this is the same thing. But oh, it's not a function for both any input. So yeah, that's kind of fun. And then we just go on and on. There's a fun question where I did infinity. To tell you the truth, this is mathematically not correct. I just find it funny to do so. And we do a little bit more domain thing. Right now, I'm trying to change it to this form because I do not like this form I made a long time ago, which is being a pain in the ass. I have to manually do this because, yeah, I just have to manually do this stuff. It's a little bit awful. I've been doing it over here and it's painful. And you can kind of see. I love the cool domain. Anyway, that's probably what I've been working on. I'm changing basically all the things I've written in pen and digital tablet and or some weird way with the mouse and changing it to latex if I did that because it's much better. Uh, if it's yeah, it's just better in my opinion. All right, we're done here. We have done talking. Hopefully you had fun, learned some. Nah, you probably didn't learn anything. This is like basic one-to-one stuff in like elementary or middle. We're not really doing anything special. Oh, yeah. And then we'll go to even functions. Yeah. It's gonna be a long while until trigger calculus where everything gets fun. We might actually skip to that because I'm getting bored. Anyways, I'm just gonna stop sharing.